विद्यार्थियों, आज दे इस पाठ विच तुहाडा स्वागत है। अपनी पहली क्लास विच असीं वैक्टर अलजबरा ते विचार कीता सी। इस विच असीं ग्राफिकल मैथड दी वरतों करदिआं वैक्टर्स दे एडिशन एंड सबट्रैक्शन बारे पढ़िया सी। वैक्टर्स नूं ऐड करके असीं वैक्टर एडिशन दे ट्रायंगल लॉ, पैरेललोग्राम लॉ अते पॉलीगन लॉ ते विचार कीती सी। आज तुसीं वैक्टर एडिशन दे एनालिटिकल मैथड अते रिलेटिव वेलोसिटी दे कॉन्सैप्ट बारे जानोगे। असीं वैक्टर एडिशन नूं पहलां ही ग्राफिकली डिफाइन कर चुके हाँ। ट्रायंगल लॉ ऑफ वैक्टर एडिशन दे अनुसार जेकर दो वैक्टर्स इक्को बिंदु ते वख-वख दिशा विच काम कर रहे होण तां इन्हां दोवें दे मैग्नीट्यूड अते डायरैक्शन ट्रायंगल दी दो एडजेसेंट साइड्स राही रिप्रेजेंट कीते जा सकते हैं। तद रिजल्टेंट वैक्टर दा मैग्नीट्यूड ट्रायंगल दी तीसरी साइड द्वारा ऑपोजिट डायरैक्शन विच रिप्रेजेंट किया जाता है। जदों कि पैरेललोग्राम लॉ ऑफ वैक्टर एडिशन दे अनुसार जेकर दो वैक्टर्स एक पॉइंट ते इकट्ठे काम करते हैं तां उन्हां दे मैग्नीट्यूड अते डायरैक्शन पैरेललोग्राम दी दो एडजेसेंट साइड्स राही रिप्रेजेंट किए जा सकते हैं अते रिजल्टेंट वैक्टर दा मैग्नीट्यूड एंड डायरैक्शन पैरेललोग्राम दे उस पॉइंट तो लग रहे डायगनल दी दिशा राही रिप्रेजेंट होंदा है। तुहानूं ये भी दस्सिया गया सी कि वैक्टर एडिशन विच कम्यूटेटिव प्रॉपर्टी भी होंदी है। दूजे शब्दां विच वैक्टर्स दा एडिशन वैक्टर्स दे क्रम ते डिपेंड नहीं करता। असीं आख सकते हाँ कि वैक्टर ए अते वैक्टर बी दा सम वैक्टर बी अते वैक्टर ए दे सम दे बराबर होंदा है। दो जां दो तो वध वैक्टर्स नूं ऐड करन लई असीं पॉलीगन लॉ ऑफ एडिशन दी हेल्प लैंदे हाँ। इस मैथड अनुसार दिते गए सारे वैक्टर्स दा मैग्नीट्यूड अते डायरैक्शन सेम ऑर्डर विच किसी पॉलीगन दियां साइड्स राही रिप्रेजेंट किया जाता है। पॉलीगन दी ऑपोजिट ऑर्डर दी क्लोजिंग साइड रिजल्टेंट दा मैग्नीट्यूड एंड डायरैक्शन रिप्रेजेंट करती है। वैक्टर्स दी सबट्रैक्शन भी इसे ढंग नाल कीती जा सकती है। इहो जही किसी सिचुएशन दा सॉल्यूशन ग्राफिकल मैथड नाल देना बहुत आसान है। रूलर अते प्रोटेक्टर दी मदद नाल रिजल्टेंट वैक्टर दी लेंथ अते डायरैक्शन माप के असीं इसका मैग्नीट्यूड अते डायरैक्शन दा पता लगा सकते हाँ, पर यह वैल्यू सिर्फ अप्रॉक्सीमेट होंदी है। एनालिटिकल मैथड राही वैक्टर्स नूं ऐड करके असीं अप्रॉक्सीमेट वैल्यू नूं इंप्रूव कर सकते हाँ। असीं जानते हाँ कि किसी ऑब्जेक्ट की वेलोसिटी उसके आस पास रेस्टिंग पोजीशन विच पए किसी ऑब्जेक्ट नाल कंपेयर की जाती है, पर जे यही वेलोसिटी किसी इहो जिहे ऑब्जेक्ट के रेफरेंस विच मापी जाए जेड़ा आप मोशन विच होवे तां उसनूं रिलेटिव वेलोसिटी आखते हाँ अते मोशन नूं रिलेटिव मोशन कहा जाता है। जे ऑब्जेक्ट की वेलोसिटी किसी ऑब्जेक्ट एट रेस्ट दे रेफरेंस विच मेजर की जाए तां इस मूविंग ऑब्जेक्ट की रिलेटिव वेलोसिटी ही इसकी इफेक्टिव वेलोसिटी होवेगी। A graphical way to answer a question based on the vector addition is very simple. By measuring length and direction of resultant vector with a ruler and protractor, we can measure the magnitude and direction of the resultant vector. But using this method, we can measure approximate value only. We can improve the approximate result by adding the vectors by the analytical method. Here we continue with the analytical method of vector addition.
let the two vectors A and B be represented both in magnitude and direction by the two sides OA and AB of a triangle OAB. Then, according to triangular method of vector addition, the resultant vector R is given by the closing side of the triangle and in opposite order, that is along OB. To find the magnitude drop a perpendicular from point B to OA, this meets at point C on extended side of OA. If theta is the angle between the two vectors A and B, then angle CAB is also theta. From right angle triangle OBC, we have OB square equal to OC square plus BC square. Since OC is equal to OA plus AC, hence OB square becomes equal to the sum of OA plus AC whole square plus BC square, which is equal to OA square plus AC square plus twice of OA into AC plus BC square. From the right angle triangle ABC, we know that AC square plus BC square is equal to AB square. Therefore, OB square becomes equal to OA square plus AB square plus twice of OA into AC. Again, from the right angle triangle ABC, AC is equal to AB cos theta. Therefore, OB square becomes equal to OA square plus AB square plus twice of OA into AB cos theta. Since OA is equal to magnitude of vector A, AB is equal to magnitude of vector B, and OB is equal to magnitude of vector R. Therefore, the equation becomes R square equal to A square plus B square plus twice of AB cos theta, or R is equal to the square root of A square plus B square plus twice of AB cos theta. To find the direction of the resultant, let us consider that vector R makes an angle beta with the direction of vector A. Then, from the right angle triangle OBC, tangent beta is equal to the ratio of BC and OC. This can be rewritten as tangent beta is equal to the ratio of B sin theta and A plus B cos theta.
I hope you do not have any doubt regarding the vector addition by analytical method. Let me just revise it in the light of parallelogram law of vector addition.
Let us consider two vectors A and B inclined to each other at an angle theta, represented in magnitude as well as in direction by sides OA and OD of the parallelogram OACD. According to the parallelogram law of vector addition, resultant of vectors A and B is represented both in magnitude and direction by the diagonal OC of the parallelogram. From right angle triangle OBC, we have OC square equals to OB square plus BC square. Since OB is equal to OA plus AB, hence OC square becomes equal to the sum of OA plus AB whole square plus BC square, which is equal to OA square plus AB square plus twice of OA into AB plus BC square. From the right angle triangle ABC, we know that AB square plus BC square is equal to AC square. Therefore, OC square becomes equal to OA square plus AC square plus twice of OA into AB. Again, from the right angle triangle ABC, AB is equal to AC cos theta. Therefore, OC square becomes equal to OA square plus AC square plus twice of OA into AC cos theta. Since OA is equal to magnitude of vector A, AC is equal to magnitude of vector B, and OC is equal to magnitude of vector R. Therefore, the equation becomes R square equal to A square plus B square plus twice of AB cos theta, or R is equal to the square root of A square plus B square plus twice of AB cos theta. To find the direction of the resultant, let us consider that vector R makes an angle beta with the direction of vector A. Then, from the right angle triangle OBC, tangent beta is equal to the ratio of BC and OB. This can be rewritten as tangent beta is equal to B sin theta divided by A plus B cos theta.
I hope you have understood the analytical method of vectors addition. Tell me, if two vectors are to be added, what is the condition to get the maximum value of resultant vector? Simply, when the value of cos theta is maximum, then theta is equal to 0 degree, or the two vectors A and B are parallel to each other. The magnitude of vector R is simply the algebraic sum of vectors A and B. Now, tell me again, if we add these two vectors, what will be the condition to get the minimum value of resultant vector? Simply, when the value of cos theta is minimum, that is, when theta is equal to 180 degree, or the two vectors A and B are parallel and opposite to each other. And the magnitude of vector R is simply the algebraic difference of vectors A and B, that is, A minus B or B minus A. For more clarity, let's try some numerical problems. Two displacement vectors of same magnitude are combined together. Let me know how to combine these two vectors to get a resultant displacement of same magnitude. Here, let us consider two vectors of same magnitude of vector A and vector B. Let the angle between them be theta, so that the magnitude of the resultant vector R is equal to the magnitude of vector A or vector B. On substituting the value of A, B and R in the relation for vector addition, we get A square equal to A square plus twice of A square cos theta, which gives theta equal to 2 pi by 3. The next problem is, if two vectors, vector A and vector B, are perpendicular to each other, can you prove that the magnitude of vector A plus vector B is equal to the magnitude of vector A minus vector B? Since vector A is perpendicular to vector B, angle theta is 90 degree or cos 90 is 0. Therefore, the magnitude of vector sum is equal to square root of A square plus B square. Similarly, the magnitude of vector difference is also equal to square root of A square plus B square. Therefore, the magnitude of sum as well as the magnitude of difference of two mutually perpendicular vectors is same. Similar to addition, we can subtract two vectors. Best application of the vectors subtraction is the relative velocity. We know that the velocity of an object is always measured with respect to a surrounding object at rest. But when velocity of the object is measured with respect to an object which is also in motion, the velocity is called as relative velocity and the motion is called as relative motion. The relative velocity of an object with respect to another moving object is simply an effective velocity of the object with which the object will appear to move when the other object is considered to be at rest.
Let us consider two objects A and B are moving with velocities vector VA and vector VB inclined at an angle theta. To find the relative velocity of object A with respect to B, we superimpose velocity minus vector VB on object B so that the object B comes to rest. To nullify this effect, we superimpose velocity minus vector VB on object A also. Now, object B is at rest and object A has two velocities vector VA and minus vector VB, and these two velocities are inclined at an angle of 180 minus theta. Therefore, the relative velocity of the object A with respect to B can be measured with the help of vector addition method. Relative velocity of object A with respect to B is vector VAB, which is equal to vector VA minus vector VB. So, the magnitude of the relative velocity of A with respect to B is equal to the square root of the magnitude of vector VA square plus square of the magnitude of minus vector VB plus twice of the magnitude of vector VA into magnitude of vector VB cos 180 minus theta, which is equal to the square root of VA square plus VB square minus twice of VA VB cos theta. If relative velocity VAB makes an angle beta with the direction of VA, then tangent beta is equal to the ratio of VB sin theta divided by VA minus VB cos theta. In this example, a car is moving with velocity of 10 km per hour, and if the rain is falling vertically at the rate of 20 km per hour, then the relative velocity of rain with respect to car is 22.36 km per hour, and it makes an angle theta with the car, which can be measured as tan theta, equals to the ratio of speed of rain to the speed of car, which is equal to 2. Therefore, theta is equal to 63.44 degree.
Now, can you tell me what will be the relative velocity of the object B with respect to object A? Well, it is equal to the square root of VA square plus VB square minus twice of VA VB cos theta. If relative velocity VBA makes an angle beta with the direction of VB, then tangent beta is equal to the ratio of VA sin theta divided by VB minus VA cos theta. If both the objects are moving in same direction, then the angle of inclination between them becomes 0 degree, and hence magnitude of the relative velocity of object A with respect to object B is equal to the difference of the magnitude of velocities of objects A and B respectively. And if both the objects are moving in opposite directions, then the angle of inclination between them becomes 180 degree, and hence magnitude of the relative velocity of object A with respect to object B is equal to sum of the magnitude of the velocity of object A and B. Before we conclude today's topic, let us try some numerical problems based on relative motion. On a certain day, rain was falling vertically with a speed of 25 meters per second. Let a cyclist be going at a speed of 10 meters per second in north to south direction. What should be the apparent speed and direction of the rain with respect to the cyclist? Here in this problem, velocity of rain is 25 meters per second and the velocity of the cyclist is 10 meters per second. Suppose the relative velocity of rain with respect to the cyclist is V and makes an angle theta with the vertical. Then the apparent velocity of rain or the relative velocity of rain with respect to the cyclist is equal to the difference of velocity of rain and velocity of the cyclist. Since the angle between rain and the cyclist is 90 degree, therefore, the apparent velocity of the rain is equal to the square root of VR square plus VC square, that is 26.92 meter per second. For direction, tan theta is equal to the ratio of VC and VR, which is equal to 10 upon 25, that is 0.4, that is theta is 21 degree 48 minute with vertical towards south. In the next problem, let a boatman row with a speed of 20 kilometers per hour in still water. If the river flows steadily at 5 kilometers per hour, in which direction should the boatman row in order to reach a point on the other bank just opposite to the point from where he started. Let the width of the river be 1 kilometer. Let the boatman start from point O and reach the point P on the other bank. Let the boatman make an angle theta with OP or make an angle 90 plus theta with the river so that after being directed by the water current, he rows the boat along OP. If the velocity of boat in still water, that is VB, is along OA and the velocity of water, that is VW, is along OB, then the resultant velocity of the boat or the relative velocity of the boat with respect to water should be along OC. From the right angle triangle OAC, sin theta is equal to the ratio of AC and OA, which is equal to the ratio of OB and OA, that is equal to VW upon VB or equal to 5 upon 20. Therefore, theta is equal to 14 degree 29 minutes. In the same problem, what is the relative velocity of the boat with respect to water? It can be calculated as the square root of VB square plus VW square minus twice of VB VW cos 90 minus theta, which is equal to the square root of VB square plus VW square minus twice of VB VW sin theta. So, the relative velocity becomes equal to the square root of 375, that is 19.36 kilometers per hour. Whereas, for the direction, let the relative velocity make an angle alpha with the direction of the boat. Then, tan alpha is equal to VW cos theta divided by VB plus VW sin theta, which is equal to 5 cos theta divided by 20 plus 5 sin theta. Since sin theta is 0.2500, so cos theta is 0.9683. Therefore, tan alpha is equal to 4.8415 divided by 21.25, that is 0.2278. Therefore, alpha is equal to 12 degree 50 minutes. Let us now summarize all that we have learned so far. If theta be the angle between two vectors A and B, then the resultant vector r is equal to the square root of a square plus b square plus twice of ab cos theta. And for the direction, if vector r makes an angle beta with the direction of vector A, then tangent beta is equal to the ratio of b sin theta and a plus b cos theta. If two objects A and B are moving with velocities VA and VB inclined at an angle theta, then relative velocity of object A with respect to B, that is vector VAB, is equal to vector VA plus minus of vector VB. So, now we come to the end of today's topic. Let's have a quick question answer session. My first question goes like this: what is the magnitude of the resultant vector if we add two vectors A and B inclined at an angle theta? The answer is the resultant vector r is equal to the square root of a square plus b square plus twice of ab cos theta. The next question is, what is the direction of the resultant vector if we add two vectors A and B inclined at an angle theta? The answer is, if vector R makes an angle beta with the direction of vector A, then tangent beta is equal to the ratio of B sin theta and A plus B cos theta. The next question is, define relative velocity. The answer is, when velocity of the object is measured with respect to an object which is also in motion, the velocity is called as relative velocity. ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਸੀਂ ਅੱਜ ਦੇ ਪਾਠ ਦਾ ਖੂਬ ਆਨੰਦ ਮਾਣਿਆ ਹੈ। ਹੁਣ ਅਗਲੀ ਕਲਾਸ ਵਿੱਚ ਫਿਰ ਮਿਲਾਂਗੇ। ਧਿਆਨ ਦੇਣ ਲਈ ਧੰਨਵਾਦ।